Depends on the airplane and everything else. But if we're learning techniques, you have to learn how to let go. Got to put you in an airplane at a severe bank angle or in a spin and say, okay, now let go. We have to learn how to do that. Pilots tend to be a little bit control freaks. You know, there's the ground, I go pull that yoke back harder. So again, if we can learn that, we can learn the warning sign before that and relax enough. Because why am I in a spin? Hanging on too tight to the rudder and the elevator, right? So if I were relaxed enough, I wouldn't have to let go later. So they do kind of go hand in hand, but it's not always as simple as that. Always. Not always. Okay? Any other questions? We had some over here. Let's go right there.
What lesson can you remind me of cornering flight at 0G to maintain controllability of angle of attack and 0G flying?
Okay, ask your question one more time.
When you're at 0G, you can fly at a higher angle of attack and maintain controllability. Is that a correct statement? Or?
Yeah, the question has to do with flying at 0G. How do we get to 0G? By pushing, right? And pushing does what to angle of attack? It drives it down, right? So theoretically then, I should be able to fly at 0 speed and 0G, right? In fact, if I'm going to try to fly momentarily at 0 speed, I must go to 0G, right? Right? So there are speed and G combinations that lead to stalling. Wings level has a certain stall speed at 1G, right? And then as we start adding G, like in a turn, more G, higher stall speed. Well, the converse is true as well. If I start slowing down, or if I start shedding G, I can fly at a slower speed. Now, of course, we can't fly at 0 for very long, unless you're in a helicopter, right? But at the top of a hammerhead, when the pilot's going to turn around, 0 speed, 0G. Right? And in fact, if I can get the G to 0 as the speed gets to 0, can it stall at 0 speed? What's the definition of a stall? Yeah, and what happens there? Airflow separates. What if there's no airflow? It can't separate. I can't stall. The airplane sitting on the ramp here, are they stalled? They're just sitting there. Certainly more stable at 0 speed on the ground. In the air, it would be kind of a momentary, a ballistic sort of thing.
And does negative G get you any further advance?
So now the question is negative G. Every time we draw a performance graph, lift and drag, or speed versus G, there are always two sides. The bottom of the wing or the top of the wing. If you go negative, now you have a negative angle of attack, you have a negative critical angle of attack, you have an inverted stall, right? So knowing that, let's say you're in an aerobatic airplane, we can go either way, at will. Where's the safest place to put the stick if you don't know what to do with it? In the middle, right? Because I'm farthest from negative angle of attack and farthest from positive angle of attack. So once we go negative, we have the same picture, usually smaller, a smaller envelope on the negative G side. Okay? So we're just flying a different side of the wing, but angle of attack is there, airflow separation is there, all of those other things. So 0, 0 is kind of that magic transient spot that we can feel on occasion.